Welcome to the RapidMiner workshop on outlier detection. So brief introduction into what we're going to be doing today is we'll be taking a look specifically at outlier detection methods in RapidMiner. So we'll take a look at the outlier detection options in the RapidMiner auto model. We will also be looking at how to build out a process that does outlier detection. And we will be extensively utilizing the anomaly detection package from the marketplace. So we'll be utilizing the anomaly detection extension. So with that, if you do not have that installed, I have the marketplace up here. It's very easy to get to. You can go to extensions. There's a marketplace updates and extensions. And then you can just search for anomaly detection. If you search for that, it should show up. You should see this little icon here. Go ahead and select that for installation and install that package. It's gonna, it's gonna have you restart RapidMiner in order to get access to those extension operators. So go ahead and do that now. I'll give you guys a couple of seconds so RapidMiner can load up. In the meantime, if you can't access the marketplace, if it's blocked because of firewalls, you can actually access the marketplace by going to marketplace.rapidminer.com. I will put this into the GoToTraining chat, and I'll also drop the link in a comment here in RapidMiner for those following along on the video. So I'm going to go ahead and drop that. That's the full link to the anomaly detection extension, so you can actually download the jar file and install it. But you can just simply go to marketplace.rapidminer.com and access the extensions from there. So make sure you have this extension installed. For those of you following along on the recording here, we'll need to make sure you have this extension before moving forward. I'll leave that up for now, just so it's there. It's not going to make much of a hamper in what we're going to do next. So like all of the other custom workshops, what we're going to do is we're going to build a repository for our work today, our little own outlier detection project. So go ahead and navigate up to the repository panel. We'll go to the drop-down menu and we'll do a create repository like I have in my previous workshops. We're going to stick with a new local repository. Go ahead and hit next here. And what we'll cover is we'll just simply call this one outlier detection. I'll call it outlier detection workshop. I might have an outlier detection folder already, so I don't want to get an error message there. So I'll stick with outlier detection workshop. It's a little wordy, but I like it. We'll stick with the use standard location. That's fine. Once you have a name here, go ahead and hit finish. And we're just going to add a pair of subfolders onto this repository. So navigate to the outlier detection workshop. Right-click on that repository entry and do create subfolder. And if you can't right-click, you can always select it, go to the drop-down menu, and do create subfolder. We're just going to simply add a data folder and a process folder. This is predominantly going to be more of a outlier detection and data prep steps workshop. So we're actually not going to generate any models or anything with the data that we're working with. We're really only going to look at outlier detection techniques, which is why we're not going to take the full 2 hours here. Go ahead and add in a second folder. We'll just need a process folder here. We won't need a results folder. You can add one in if you like, but we're not going to need it for this one in particular because we're not going to generate anything that's not data. So go ahead and keep that as is. Once you've got a data and a process folder for our outlier detection workshop, what we're going to do is we're simply just going to add our data through this add data button. I'm not going to create a process to load in other data, as I think a lot of those techniques have been covered in all of the previous workshops. So what we'll do is we'll just simply pull the 2 files that I've sent you into RapidMiner. So again, make sure you go to the Materials tab, access the there should be a service center metrics.csv and a service metrics 100w.csv. We're going to make sure to download both of those, so go ahead and hit open file for those materials. If you're following along with the recording, we'll have those materials available for you. So go ahead and download those now. Put them in an easily accessible location. Your downloads folder or your desktop are the two places that come to mind. I usually keep everything right on my desktop. It's just easier that way. Once you have those downloaded, what we're going to do is go to this Add Data button here up at the top of the repository panel. Go ahead and click on that. It's just simply going to ask you where your data is. Is it on your local machine, or is it connected through a database? For our case, since we're working with these flat files, it's going to be on our computer. Excuse me. So we'll have to select the My Computer option. With that, go ahead and navigate to the desktop. Or wherever you stored this data, rather. I'm going to navigate to my desktop because I have these data sets stored there. So the first one we'll pull in is going to be the service center metrics.csv. This is going to be the main data set that we're going to work with. And go ahead and hit next here. So now this data set's pretty straightforward. What we're going to be looking at is we're going to be looking at an auto parts shop retailer data set. It's pretty easy to understand, and it works great with the outlier detection operators. The use case here is going to be detecting shop sales revenue as well as outliers in individual part sales. So that's what we're going to be centered around here today. There should be a materials tab in the little go-to training bar. You guys should have access to it if I double check that. I do have the attendees can view materials. In that materials section, you should see 2 CSV files. Let me know if you can find those. All right, not to waste time while we wait here. So for those of you that are following along, this add data option should format the CSV just fine. So it should default to the semicolon. It asks for a header row. We do have a preview of the data here. Everything looks fine. So what we can do is go ahead and hit next here. Once you're here, we can deal with data types here. I think everything for the most part is numerical, so we don't have any problems. The only thing that wouldn't be would be our shop ID. So what we can do here, because this is an ID and we don't necessarily need to worry about this from an anomaly detection perspective, what we can do is tell RapidMiner specifically that this item here is an ID. So go ahead and navigate to our shop ID. And what we're going to do is we're simply going to go to the change role option. So you'll hit the little cog up above and you'll do change role. And then it'll just simply ask you to navigate to the drop-down menu here. We've got label, ID, or weight. We're going to stick with ID here. Once you do that, we don't need to change any of these other options except for the data type for the shop ID. Since we don't want this to be numerical, what we can do is we can do change type and then go to polynomial. So go ahead and access the cog here and we'll do change type and we'll do polynomial. All right, once you have the shop ID set up, there is it does tell us that there are no problems with this data set, so go ahead and hit next. What we're going to end with is we're simply just going to store this data into our data folder. It should extract the file name out, which is Service Center Metrics, and we'll go ahead and leave that as is. I'm going to hit finish here. It should open that data up in our results panel, so you should see our shop ID here. The data set's pretty straightforward, so I'm going to talk about this and then we'll upload our second data set. Basically, we have a set time period, and then we also have a shop number. So there's shops, I believe, 1 through 12. No, there's many shops. Okay, so there's way more. So there's 50 different auto part shops, and there are 10 time periods listed for them. So we've just segmented into 10 options for each shop. Basically, what we have is we've got individual part sales for part 1, part 2, part 3, part 4, and part 5. Those 5 parts in particular are can just, maybe we've got different engine components for reference. Maybe this is an engine block shop. The parts are irrelevant, but just to note that these represent retail items. And then the last piece is that we have the total revenue over this time period. Some of this seems like a whole lot of sales, so could possibly be an engine parts shop. I don't know what would bring in this type of revenue. This revenue seems a little high, but we'll stick with it and we won't question it just for the example today. So we're going to take a look at a couple of things. We want to look at outlier detection. We want to detect shops, whether it's and their which periods are basically are either selling too much of one part or if the revenue's off. Basically, we want to use outlier detection as a method of identifying potential fraud from a retail perspective. So for reference, if we have something like a really high revenue, but the part sales are not outliers, something weird's going on there, or for reference, we have a really low revenue on the flip side and we have standard part sales, something weird's going on there, or if one shop sells a particularly large amount of a single part, but the revenue doesn't make sense, then there might be stuff worth looking into in the data set. So this is very much kind of a fraud use case from an outlier detection perspective. What we can do now is if you jump back into the design window, we will go ahead and access this data set as well. If you navigate to the Add Data button, we'll do the same step. So it'll be off of my computer, and we'll grab that second data set and bring it into RapidMiner. I'm going to just simply navigate to my desktop. Let's see, the second one was service. We're going to look for service metrics 100w.csv. Once you have that, go ahead and hit next. Our data format should be fine. We have a semicolon again, so the data set looks like it's structured correctly. This time around, if you want to see how this scales from a dimensionality perspective, we've got 5 parts here, and then I have a whole host of other dimensions that are added into the data set, whether it's different part sales, individual part revenues, and it can be any host of metrics. So we've just generated some extra dimensions here to add on to this data set to see how the anomaly detection works. So we can use this after we use the smaller data set. So we're going to use the small data set to teach with just because it's fairly simple and easy to understand, and then you can check this and see how it scales up with extra dimensions added in. So go ahead and hit next here. We're going to do the same thing we did before. Go ahead and select shop ID. We're going to change its data type to polynomial, and we're also going to change its role. And then I'm going to hit change role here, and there should be a drop-down menu for ID. And I'm going to go ahead and hit OK. Everything else in here is fine, so we can keep this as is. I'm going to go ahead and hit next here. It's simply just going to ask me to store the data again. So I'm going to grab the data folder. It should extract out the name here. So we're going to do service metrics 100W and hit finish. All right, we can continue on here. What we're going to start with is I'm going to go into the design option here. I'm going to remove my sticky note. What we're going to work with is first is we're going to take a look at the auto model and what it produces for us. In particular, I want to take a look at the outlier detection options in the auto modeler. So we can start with a template that the auto modeler will give us, and then we can work through different outlier detection algorithms together in RapidMiner Studio. So we'll build them out one-on-one here. So let's go ahead and navigate to the Auto Model tab. If you are on a trial or have a RapidMiner license, you should have access to the Auto Model tab. If you do not have access to the Auto Model, if you are on the free version, just sit tight. You can follow along. Since we're doing using the Auto Modeler, it's fine to just see how it gets utilized here. There's nothing too groundbreaking that you'll see. I just wanted to show you guys what are the auto model options for detecting outliers and walk you guys through how to use them. So this is where we'll start today, but we'll be very much just building out our own anomaly detection options later on. So let's go ahead and navigate the auto model. The first option is to simply select some data. So we can go ahead and navigate to the Outlier Detection workshop. And in that data folder, we should have two data sets. We're going to stick with the service center metrics. It's the smaller of the two data sets. And we're really looking to teach here, not so much do some in-depth analysis on the number of dimensions that affect outlier detection. So let's go ahead and select the service center metrics here. Once you have that, go ahead and hit next. What you'll notice here in this step is RapidMiner simply asks us if we want to predict something, do we want to identify groups, or do we want to detect outliers in the data? Well, matter of fact, this is the outlier detection workshop. So we are going to do some outlier detection. So go ahead and hit the select the outliers button. Now we don't have to do anything else. Notice that, like, for example, when we do predictions, like we've done in the previous workshops that ask us to select a target in our data set. For outliers, we don't need to worry about anything. Once it's selected, we can go ahead and hit next. Now, our data set in this case is actually fine. There are no quality issues with our data set, which is good. So the data set is pretty clean. There's no missing values or anything like that. So we won't have to do any extensive ETL work. We simply just want to take a moment and detect outliers in our data set via different outlier detection methods. So here, there's probably a few columns we don't necessarily want to use, but they are useful to have around. The idea is we've got period here and our shop ID for reference. Both of these that are important to us because it tells us what shop we're looking at, as well as what the period is that these sales quotas and revenues are coming in for. However, I don't necessarily need to detect outliers in this case, but having them in my process will be fine for now. What we'll look at is trying to have RapidMiner ignore these metrics when we do our outlier detection, and we'll do that in a creative way. Let's go ahead and hit next here. The next option is just to select model type. So I believe there are only 2 options for outlier detection here, and I don't believe that the outlier detection methods are very robust in the default RapidMiner operator set, but that's where the anomaly detection extension comes into play. So for reference, we should just get a distance-based outlier detection and a local outlier factor option. I believe it's just going to stick with the default settings unless we tweak the percentage of outliers. We'll keep this at default because I really just want to take a look at the process that RapidMiner builds and the results that the auto modeler generates. So let's go ahead and hit run here. So you should get 2 outlier options. You should have the distance-based outliers and the local outlier factor. So for the distance-based outliers, what we're going to get is a true-false. It's simply going to identify whether or not something is an outlier, but it's not really going to tell us any analysis about that. We'd have to actually go in and try to break down why this item in particular is an outlier. The flip side of this is actually the local outlier factor, which instead gives an outlier score. So for reference, in this case, we've got, we'll actually get a score in which we can identify what is the what our threshold is that we want to keep. So each one of these algorithms is going to have extensive documentation. So what you can do is you can crack open the documentation page or the help window and actually see how this local outlier factor is making this score. For reference, 5 and 2 are relatively high. I would even say 1.5 or above would be high. So these would be on the extreme side of our outliers, this one in particular. And you can see here the parts don't look too out of order, and neither does the revenue. So there's probably some in-depth analysis that we can tack on here to figure out what's driving these outliers. But if you trust the outlier scoring, it's fairly easy to add in a filter to take out outliers based off of their score. And if I go back into the data here, I can easily filter on the true-false options. So I can simply just take out anyone whose outlier is equal to true and move from there. So what I want you guys to do is go ahead and open up the local outlier factor option, and I want you to open up that process. So this one's fairly straightforward. It does a lot of data prep steps. A lot of this we aren't going to have to worry about when we build out our process. So there's some general pre-processing. So these are all of those data integrity tests and make sure we don't have any missing values and make sure the process runs smoothly. For our case, our data set's actually pretty prepped. So what we'll want to do actually is just kind of feed this into different outlier detection methods and actually get an idea of how our data set reacts, and then maybe we can identify some specific ongoings in the data set. So what we'll do now is we will, I'm going to go ahead and store this because it's nice to have the auto model result reproducible. So let's navigate to the process folder. I want you guys to right click on the process folder and do a store process here. We're just going to call this one 001 auto detection. Go ahead and hit OK. So it should store that process. And what we're going to do is we're going to start with a new blank process. There's a whole lot of data prep going on here, and we don't necessarily need to worry about that. So let's go ahead and create a new process. And what we're going to do is we're going to go ahead and grab that service center metrics and place that onto the process window here. I'm going to hook that up to my result node, and then I'm going to come into my operators panel. I believe we should just have a folder. In my cleansing folder, there's actually an outlier folder. So there's, I believe, the two operators that were used were the detect outlier distances from the auto modeler and the detect outlier local outlier factor. There are a couple other ones in here. So there's class outlier factors, and then there's also local detect outlier density. So these are the two that are being used by the RapidMiner auto modeler. This looks at neighbors. I can actually come in here and tweak these, which might change the results different from the auto modeler, because the auto modeler just uses the default parameters. So how I calculate my distance between data points might have a drastic implication on what gets detected as outliers. This probably also has a lot to do with the distribution of our data and the type of data that we're working with. So the default's the simple Euclidean distance, which is a pretty easy calculation with a small number of dimensions. And then if you want, you can actually read up on what the algorithms that our auto modeler build was doing. So we can easily set this up to run both algorithms. So what I want you to do is actually grab the multiply operator. Once you have the multiply operator, I'm going to place it onto the retrieve service center metrics between that and the detect outliers distances. And I'm going to go ahead and just send the second output to the detect outlier local outlier factor. So what the multiply operator is doing is not doing any sort of multiplication, but what it's actually doing is duplicating my data set at this point. So now I can take my data and I can send it out to multiple algorithms. This is pretty handy when we want to test a whole bunch of different outlier detection options. Something else that I want to do to the data before the multiply, though, is I want to tell the data specifically I don't necessarily want it to do anything with the period. The period is important to keep in my data set for descriptive reasons. I want to see when these sales are being made, because knowing when these different outliers are happening is important, but I don't necessarily need it to score if 10 or 1 is an outlier and so on. So I need to make sure that RapidMiner knows not to do anything with this column. So what I'll have to do is I'll have to add in a data type change. So I'll have to go numerical to polynomial. So go ahead and do capital N, capital P. I'm going to go ahead and drop that in. It's automatically going to ignore the ID, so we don't have to worry about shop ID being run in here. But what we'll need here is we'll need to simply say single, and then we'll also need to select the period. Another thing that we could do if we wanted to keep it in a numerical data type is we actually could change our period to a special role. So we could just lie to RapidMiner and say, hey, don't touch this because it's a special rule. For our case, we can just set it to polynomial because I believe that should work. Once you have that, you can start to play around with the outlier options here. So both of these are going to be distance-based calculations. So I can define my number of neighbors, my number of outliers, and my distance function for either of these. This is a very simplified version of what the auto modeler does. There's a whole bunch of pre-built steps that the auto modeler always does with the data. For example, make sure to downsample to 500,000 rows and checks to make sure you have 500,000 or less. That's one of the operators in there, but this is a very streamlined version of what the auto modeler does. So yes, the auto modeler is useful, but if you know your way around RapidMiner, that's also very useful as well. Now go ahead and run this process. So I could tweak some of these. I can now filter on my outliers. So notice with this outlier factor, I get a larger range of outliers. So for my outlier factor in this case, I have quite a few outliers comparatively. So remember, we could add in that filter and just simply say anything above 1.5 I'll want to flag as an outlier, and then I can take the filtered out data set and actually drill down into what's going on here. So in this case, I'm getting an outlier score, but I'm not getting anything in terms of useful analysis here. What I could do is I could look at statistics for each part and get an idea of where each part is relative to, for reference, the average or the standard deviation, to actually see if a part is below that option. So what we could do is add in some steps where we extract out the average and standard deviation for a column, and then we compare our value to that and find out the difference in these values, which is something we're not going to do because we're actually going to use an operator from the anomaly detection extension that'll actually do a lot of this analysis for us, and it'll even give us a visual output to check that. So what I want you guys to do is go ahead and right click on the process folder. We're going to do store process here. We'll call this one 002 RapidMiner outlier. And so we'll continue working with this process because what we can do is we can go ahead and add in new columns or new operators into this list. So because this data set's relatively small and it runs fairly quickly, what we'll do is we'll just continue to add on new outlier options. If you do want to not have specific outliers detection algorithms run, what you can do is just simply enable or disable operators by selecting them and hitting Control E. It'll disable out the operator, so you'll see it grayed out like so, and you can easily re-enable it by hitting Control E again. I'm going to leave them hooked up because these run relatively quickly, so I don't need to worry about it. The next outlier detection algorithm that we're going to search for is going to be HBOS. So I'm going to do capital HBOS, which is going to be histogram-based outlier scoring. So we're going to use the histogram-based outlier scoring for our data here. So go ahead and drop that onto the process. So I'm going to hook the third output up here. For some reason, it looks like there's a bit of a metadata disconnect with the histogram-based outlier score. Our output ports aren't highlighting blue, but don't worry about that. The process will still run. Go ahead and hook up both of these outputs. So you notice that with the outlier detection, we have the standard EXA input and output and the ORI output, like most of our data prep steps. For our histogram-based outlier scoring, there's two outputs. There's the EXA port, which gives us simply the outlier score, just like our local outlier factor. There's also a second output that gives us a visualization. It actually gives us a bit of a heat map across our data set. So that's why that second output is different, is because it's not an ORI output, it's instead a visualization. So what I want you guys to do now is go ahead and run this process. So once you run that, what you should get now is you should get we should get 3 outputs. Did this one have? Oh, it did. Okay. This is the score. Okay, perfect. So the example set multiply should be the actual score from the histogram-based outlier score. And then the other output will be this outlier example set histogram-based outlier score. So much like the local outlier factor, we can just trust the HBOS in here to deliver us a score, and then we could simply add in some filters based off of that score. What we can do now is take a look at the outlier example set. If we take a look at this, this is why the HBOS is really handy in that anomaly detection method, because before we could just simply look at the local outlier factor score, and we'd have to deem some filter worth putting on our data set. And then we could probably run a whole bunch of different metrics to actually figure out, okay, why is this one scored so high? How do its columns react differently than the rest of my data? What the HBOS allows us to do is actually get this visually. So I can come in here. I've got my different parts 1 through 5, and I can sort based off of these different columns. So I can start to see here, for reference, these two have a high score when it comes to part 1, in part that they have sold parts 1 much more than any other stores. And on the reverse of that too, if I sort the opposite direction, I see that there is a time period here in shop 1 where they sell no parts. So this ends up being a bit of an issue. So I can identify different shops by their ID now based off of what they sell. So what I can also do is just go by score. So if I look at just the top set of outliers, I can actually see what the driving factors are for these outlier predictions. So this score is high in particular because we have sold a large amount of parts 1 and 2, but our revenue is relatively stagnant. So this could represent a case where an employee is handing out a discount, or maybe there's a computer error and stuff went on sale and people bought them in bulk. I know that that's a common Amazon problem back in the day. Someone would put a 0 in where there should have been a 1, and people could buy some particularly expensive items in bulk for very cheap, and then they could easily resell them. So something weird could be happening in this case, but it's pretty identifiable now, simply because we can actually look at this and understand that 47 of part 1 and 47 of part 2 is a problem. That's not normal. It's not necessarily a problem, but we're selling, and that's not a lot of that quantity, and that's not normal because our revenue is pretty normal. And then there's quite a few other outliers where revenue is relatively high, but part sales are relatively stagnant. And you can see that here. So what's driving those revenues up is unclear. So maybe maybe we can start to flag shop IDs and drill down into why revenue was up so high. Maybe there were some in-shop deals on services, which was why the revenue was high this month. You don't really know, but you'd be able to actually push this down, automate shop selection processes based off of the outlier scoring in this case. But here we can get a good visual representation of this as well. If you guys would excuse me for just one moment. All right, my apologies for the brief delay there. What we'll do now is we'll take a look at some other anomaly detection options as well. This HBOS is pretty unique because it actually gives us a breakdown of what's actually happening across the different parts. What we can do now is actually go into our design. I'm going to go ahead and remove well, I guess I'll disable them. I won't delete them. I'll disable the two that come with RapidMiner Studio. And what we'll do is we will open up that anomaly detection extension and take a look at some of the other options that are available. So for reference, there's a nearest neighbor based, which if you've taken the RapidMiner training, we get pretty familiar with the nearest neighbor machine learning algorithm. So in here, there's a KNN global anomaly score, as well as a, actually this is the same local outlier factor that we had before. So go ahead and grab that KNN global anomaly score. And so this will work the same way our nearest neighbor machine learning algorithm works, in that we'll make a nearest neighbor calculation, and we can define the K value just like we can in the machine learning algorithm. So I can also parallelize the evaluation process as well. Since I'm making so many K options, this is probably a pretty useful option for us. What we can do is we can define the number of Ks. So why don't we, there are 10 time periods. Actually, a K of 10 actually isn't too bad. But why don't we bump this up? Why don't we say, let's look at the 20 closest neighbors for our KNN for reference. What you'll notice here is we can actually utilize nearest neighbor models that we've built with this algorithm. So the algorithm itself will generate its own KNN, but it also has a model input. So I can also use my own KNN here if I've built a KNN for the data set already. So what we can do is you can go ahead and run this process now. So now notice that this score is a bit different than the previous options. So if I take a look at this and filter here, where the other one was more on a normal distribution, this one actually just gives you the total overall distance as an outlier option. So again, each algorithm is going to have its own outputs and based off of the actual calculation that's being made. So some of them might be a little bit more relevant to specific use cases or data sets. So really it's a matter of figuring out which algorithms are a good set for your data set. And there's actually quite a few to choose from. What's also actually going on here is because the KNN is actually spending most of its time building out the model, our data set's relatively small, so we're not going to see this. What we could do here is we can actually store this model. So if I drop in a store operator, I can store this outlier detection KNN. I can go to my repository entry here. We'll actually now need a results folder. So let's create a results folder first. I'm going to right click and do create subfolder. And I'm just going to make a results folder. So unlike a machine learning model, this is going to be a similar model object, but it's not going to be machine learning. So you'll notice the output's gray instead of green. Go ahead and place this into that results folder, and I'm just going to call this one KNN outlier, and hit OK. Now I'll have to rerun this process in order to store the model, so I'm going to go ahead and rerun that quickly. And then if I go into design, I should see my KNN outlier here. And what I can do to speed this process up, again, it's not going to make much of a difference because this data set's relatively small. I can use that model as an input. So if I were to, for example, take the next year's worth of stores and want to deploy out this model, what I can do is I can just take in the new data, call this KNN model, run it as the input for the KNN global anomaly score, and then run this process. So notice it runs a little bit more instantaneously because it's just simply applying that KNN model to the data set instead of building the KNN itself. So that's what this model input and output option is for. I'm going to go ahead and store this process now. I'm going to call this one 003. We'll do HBOS and KNN. All right, so the last option that we're going to roll with is I'm going to say let's focus on the HBOS for now. So for this last process, I'm going to remove the KNN global anomaly score. I'm going to remove the multiply, and I'm going to remove our two others. And what we're going to do is we're going to hook this up like so. And we're actually going to work with our results view. So if I jump into my histogram-based outlier score, I want to take a look at the score for this data. And so as I look through here, I have a lot of relatively high revenues for most of these outliers, even though part sales are fine. So I probably can pick a threshold here. I'd say probably 1.5 would be fine. It gives us some high revenues with standard part sales, but it gets rid of most of the problem children up here. So this is where part sales, individual parts, start to go wild. What you could do too is actually get a score for each individual part sale as well. So for reference, what we could do is actually loop this if you wanted to actually get an outlier score per column. We could loop our attributes in this case through an outlier detection algorithm. If that's something that you wanted to do, it would look like this. So let's go ahead and grab a loop attributes. So if I do capital L, capital A, I might have to type in loop here. There we go. I'll show you guys how to use this loop here. Go ahead and come inside of this loop attributes operator. And what we're going to do is we are going to grab our HBoss. And then we are also going to grab a we don't need to select attributes because loop attributes is going to do that for us. So I want you to go into the loop attributes parameter, so don't select the histogram-based outlier score. Go into the loop attributes parameters and do single. And then what we're going to do is we're going to hit the %, curly bracket, loop underscore attribute. And what this will do is this calls our loop attribute macro that's being built by the loop. So the loop's going to take each attribute. And basically I can run this now. Does it actually? Oh, okay. I can't call. Am I missing a curly bracket on there? Looks good. No, I think what I want to do actually is select all of the attributes because this is what I'm going to be looping over. And okay, my first hunch was right. I want to select attributes here. So I'm going to drop in my select attributes. And this time I'm going to do single for my attribute filter type. And then for my attribute, I'm going to use the loop attribute option. This is where setting my, what we did here, our time period to a special role would come in a little more handy because this is still going to not keep that in the data set. But what this will do now is this will loop my outlier score just for individual parts. So I can actually see what are the weird part sales for each individual part. What I could do is I could bring in all of these scores into the data set based off of parts. So I could, for reference, also add in another loop. So that should output here each of the different outlier scores for the revenues. And what I could do is I can come into here and say we want rename. So we can use a rename operator. And this is going to be for the score, I believe. And our new name will be score underscore %, loop underscore attribute. So what we can do now is feed in this rename, this macro here. What I'll do is I'll copy and paste this into the chat so you guys have it. And I'll hit send here. So then I can run this, and what it should do now is it should create a score and also name that score for each part. So if I wanted to now bring all of these data sets together, I could join them up. I actually probably would need 2 columns here, so I would have to probably tweak this in another way. So once you've run that, what I want to do is go up to the top process, and then I want you to go like so, and add in a set role operator. If I do capital S, capital R, I should get a set role operator. And then what I want to do here is select our period. And I simply can call this pretty much anything that's not an ID, because we can't have 2 IDs in the data set. But what I can do is I can just do label for reference here. The other thing I could do is also concatenate these 2. So there's a couple ways of dealing with this. The easiest one is to just set this to a role RapidMiner's not going to use. But what I could do is I can concatenate. I could also concatenate my shop ID with my time period, so I can get the shop ID and time period as a single ID, so that way nothing repeats, which also would work. In this case, we're just going to tell this is a fewer steps. We're just tell RapidMiner to ignore that for now. And so what we can do is we can join these data sets together, I believe. If I go, I need to do another step though, because what I'll need to do is I'll need to reuse these results, but I can only have 1 outlier score in my data set at a time. The outlier score is a special role, just like label or cluster for reference, or weight. It's actually probably more indicative of weights, because that outlier score can be used by machine learning algorithms. So in this case, what we need to do is make sure RapidMiner can join these results together. So what we can do is we can do reuse results. If I go into, oh no, maybe not. We might have to join them all. So we don't want to append. But yeah, what we could do is we could add in another loop. So we could do something simple like set role. And we basically want to take our score columns, which is going to be score underscore %, loop attribute. Basically, we want to loop over all of the scores and just turn those into non-special attributes. So we're using a set role to remove the special attribute from that. And again, that's in the chat there, score underscore %, curly brackets, loop underscore attribute. Now, if I run this, I didn't do the underscore. There we go. If I run this, I will now get each of these, which would be my different outlier scores for each individual part and my revenue. And then I could just bring these in together. What happens when I do the reuse results? I'm just curious. I believe this appends. Yeah, so this appends the results. which isn't as useful, because what we need to do is we need to join each of these together based off of the two available columns. So we don't want to do reuse results there, but I don't want to set up all of the individual joins for the collection of objects here. I could do something fancy with the collections, but I just really wanted to show you how to loop over those individual attributes. I could bring those in. By looping over a repository and doing a join as well. So I can load in the data sets in a loop and then join them all together with that loop. We're going to not take the time to set that up here because that'll pretty much run us out of time if we sat here and tried to build that. But what we're going to do is we're going to do a store process here. We're going to call this one 004. We'll call this one the HBoss loop. So now you can do that outlier scoring with just about any data set or any outlier option. So if I wanted to just run the outliers on the different parts and then I can come up with different filters for different parts, I could do so from there. What we can do now is just simply add in one of those filters. So I'm going to go ahead and just simply delete this loop. I'm going to add in our HBoss algorithm. And then I'm going to add in a filter examples. Now, again, there's a metadata disconnect on the outside of this operator. I don't know if fetch metadata will fix it, but if we do process synchronize metadata with real data, nope. There's just something, there's a metadata disconnect at the end of this operator, which is why this is going to yell at us, but we can hit got it. For filters here, what we can do is just simply go to add filters. It's going to create a score column. We already know that. So we can just write in score, and then we can add in a less than or equal to. Or is it greater? No, we want to filter out greater than. Yep. So we can add in a greater than or equal to and simply say 1.5 seemed like a reasonable one given our data. So I can hit OK here. Again, it's going to be all lowercase score greater than or equal to 1.5 and hit OK. And then I can just simply run this process and it should filter. Oh, it did the opposite. I was right the first time. Okay. What we want instead is we want the less than or equal to. And hit OK. And then if we run that, it'll pull out all of the shops that were bad. So if we were doing this in order to remove outlier data before we feed it into a machine learning algorithm, we would go that route on my attribute filter score. But if I instead wanted to do some analysis on the available outliers, what I would do is I would filter on outlier score in this case. So I would take only the highest outlier scores, and then I could work through and identify which shops have the most outliers, or maybe I can make a metric for shops based off of the scores. So because there's 10 time periods, I could take the average score over those time periods for each individual shop, and then associate a risk value to that store. Really, the analysis for the outlier detection can really go further than just simply making the score. But the actual outlier detection algorithms themselves are relatively easy to use. Not only that, the RapidMiner Auto Modeler comes equipped with two of the more useful ones for outlier scoring in RapidMiner. So that's a great place to start, and then you can add on from there, whether it's just filtering out outliers. If you're working with a predictive use case and need to make sure you're not feeding the model bad data, So you could use the simple filter examples here on your outlier score to remove bad data points. Or if you particularly want to look at your outliers from a fraud-based perspective, you could add in the filter in the opposite direction to actually pull out data you want to do fraud analysis over. I've kind of covered all of the algorithms that I wanted to walk through with you guys today. This is a relatively shorter workshop. I don't know about the ones I haven't taught, but I taught the text mining one, which we took the full 2 hours on. These workshops are meant to be between 1 and 2 hours of content that we'll walk through. The idea is I can teach you this topic pretty quick. So just to recap, we walked through the RapidMiner auto modeler and how to manage the detection, building the outlier detection through the auto modeler and looking at the process that it spits out for us. Then we took those same algorithms and just implemented them in a simpler version in RapidMiner Studio. And then we took a look at the multiply operator and using that in conjunction with the HBOS and did some analysis via the visual output there. And then we built a KNN global anomaly score. We stored that model and then applied that model to speed up application to new data. And then the last piece of this was the HBOS loop, in which we ran a loop attributes over the data set in this case. So we took in each individual part, and then we ran an outlier score for those parts. The question I have in here is when do we need to use the normalize option? Actually, we probably could have normalized this data set with any of the distance-based calculations. For reference, the KNN score, it probably does a whole lot better if we normalize the data set. The biggest issue there is that the revenue is such a high number. It probably dominates the distance calculation in that regard. So you could easily drop in a normalize operator before you make the KNN option. So if I go back into here, I can remove this and I could drop in a normalize operator, and I probably would just do the Z transformation because it's pretty easy, and because this is a distance calculation, the negative value would be fine. If I could spell, that would help. I could drop in a normalize here probably, which would fix the output there. Didn't even think about that. But yeah, if I go to the KNN score now, I can actually get a much more usable output. I didn't even think of that. I just wanted to touch on the algorithm. So yeah, you probably want to drop a normalize operator in there to get a better idea of what the KNN is doing. And that means you'll have to utilize the group models, which we teach in the workshop, in the regular workshop, because I would include this normalization function with the KNN model. So that way, all I need to do is feed that model the data, and it would be able to run automatically without having to renormalize the data. You could do that as well. So the question here, you guys can go ahead and send this to the entire audience, so that way everyone can see them, but I'll repeat the questions anyway. Can you, instead of running a loop for individual attributes, just run the entire data set and just pre-select the attributes going into the outlier process? Does it provide the same results? Yeah, so are you saying instead of looping over in this case, so let's just run this quickly for part one for reference. So if I filter on part one has 4 values that are a problem: the 7, the 28, the 0, and the 47 for reference. And they all get the same outlier score actually. So instead of doing this loop attributes, you could instead manually do this, where you select out the attributes, and I can do single single part 1, and then I can run that same HBOS algorithm. And when I run this, I should get an outlier score, and I do get the same results in that case. So I can feed them the custom selections individually. It's easier to loop. In that case, I will just want to loop over one attribute at a time. So part 1, so the loop attributes, especially if I want to generate these scores for each part. Again, I'm just kind of making up a use case as we go here. Not that would be very applicable. But if I want to just do like custom part sets, like let's say, for example, parts 1 and 2 go to the same part of the vehicle. Let's just say those are both engine parts. Parts 3 and 4 are exhaust, and then part 5 is the motor for the automatic windows, let's say, for reference. In that case, I probably want to group the parts together and do outlier scores to see if there is anything weird going on with part sales in conjunctions with one another. So I could use the select attributes in that case to run this for specific part selections. This is probably a bit more useful with a data set that's a bit larger than this one. So, for example, the 100-dimension option is probably a good one for trying out those different outlier scores with different subsets of your columns. All right, I'll leave it open for some more questions. Otherwise, I'll be posting, you guys should get an automatic email. I did remember to hit record this time. During the text mining session, someone messaged me to ask if it was being recorded, and I said yes, and then never hit the record button after I said yes. For some reason, my brain just glossed over that. So I made a custom recording for that one, which is available. I did send it out to the attendee list, so if you don't have that and you are on that, please reach out to me. I can get you the link for the recording. Otherwise, the GoTo training will actually publish the recording automatically, and it'll send you a link. You'll have to register with that link in order to access the recording. It's just like registering for the workshop. It's just for you to be able to access the recording. It should stay up there for about a month, so you should have access to it. We do archive them, so if you do need it for later, just reach out to us. We should keep a recording of it. Otherwise, there's another one in July. But I'll also be hosting all of this. If you are a partner, it will be on our partner portal. So as we finish these new custom workshops, they will all get uploaded. Both the recording, the repositories, and the data will go onto the partner portal as well. All right, if you guys don't have any more questions, what I'll do is I'll give you the last, looks like 35 minutes left of the hour back to you guys. Thank you for an enjoyable workshop. As always, it was a pleasure. Again, I'm Jeff at RapidMiner, Jeff Kawanis. It's long in Polish, so I just go by Jeff C, because there's like 3 of us now at RapidMiner named Jeff. So, but thank you guys so much for showing up. I'm going to end the recording now.